So, hello students. Today in our lecture we're going to study unsupervised learning. So specifically k-means and density-based clustering. So today we're going to study two algorithms which usually used in unsupervised learning. We start from simplest one, which is called k-means clustering. So we before learned what is a regression algorithms, and today this clusterization algorithm differs from other we previously studied algorithms. We do not provide any labels, we do not provide any labels, but this algorithm has ability to differentiate into different clusters by their properties and some other parameters. Let's look from this example. Here we, like before, in the first coordinate space, we giving like some data points here without any labels, without any separation, but giving some parameters we could separate into different groups or clusters after implementing this k-means clustering. This clustering is in definition, it's dividing data points into similar data points based on some characteristics or features. Usually this clustering or division into different groups can be implemented using some attributes or based on distance. So here k-means is about dividing dataset based on the distance locations. So it can be used in, for example, in some cases dimensionality reduction, image segmentation, in search engines. So there is many applications. K-mean algorithm consists from several stages. So here k-mean clustering algorithm is used in order to divide initial given data points into different clusters, or into the different groups based on similarity. So here, so in order to divide these data points into different groups, we might provide some. So we usually provide some measure of distance, so in which will be considered like similarity. So in this range, we will look for k data points. It can be 2 or 3. We will consider. So this k-mean algorithm is iterative algorithm which divides data points iteratively into different clusters with which has similar properties. So this algorithm is also called centroid-based algorithm. So where each cluster or data set will be associated with some point which is called centroid. So the main idea of this algorithm is minimize select k points which is most close in to this centroid. So we choose some centroid, and we also provide some range, and within this range it will calculate distances between this point and collects as a one cluster which has minimum distance with this centroid. Here, as you can see, we choose some centroid, and if the distance, cumulative distance of this data point is less than some number, threshold, we group into the one cluster. Otherwise, it will be a different class. So this process, as I mentioned before, iterative process. So it iteratively divides dataset into different clusters, unless there will be no left other division process. Yeah. Here, as you can see, this k-mean algorithm implements follows two purposes. Yeah. So determine is finding the best value for k. This is a hyperparameter that we usually identified or defined by a developer, yeah, or user. And then also, so it also like automatically calculates the distances for these k data points. The general pipeline for k-mean algorithm is first we should make a scatter plot, yeah, and we also select number k, yeah, number k. So based on these data points, number of points will be classified, yeah, calculated distance. So select first, then after we select some random k points, yeah. So we, for example, initially define k as 3, and then after defining, for example, let it be 3, yeah. And so, for example, based on centroid, it calculates random 3 numbers, the distance, yeah. So then it will classify as one cluster the 3 closest numbers as a one data points as a one cluster. So we repeat this step again and again. Here we can you can see graphical illustration, yeah, in which iteratively it calculates distances. So we have also centroids, and based on centroid, it separates dataset into 3 different clusters. So as you can see here, imagine here we chose some centroids, yeah, and we also provide number k. This is the number of data points which will be randomly selected, and calculate distances, yeah, and then k numbers that we, for example, let it be 5, yeah, in this case, and these 5 closest numbers will be considered as a one cluster. So as you can see here, this one is calculated distance between data points, and then based on this distance, it will it's clustered like into separate 2 groups, yeah. So these 2 data points inside of this circle is called intra cluster, and these two data points within 2 different clusters is called intercluster. So how we calculate the distance between 2 data points here in our scatter plot? So for this purpose, usually Euclidean distance calculation is used. So here, as you can see, in order to calculate distance between 2 data points, what we did, we like taking difference between 2 coordinate space, yeah. So coordinates x2 from x1 and the y2 from y1. We take square and sum up and take under root square, yeah. So this is how we like calculate distance between 2 data points. So as you can see, using this Euclidean distance measure, we initially set like measure if we assign like k equal to 5, we say to the algorithm like take one number as a centroid and calculate Euclidean distance with every data points, yeah, every other data points regarding to this centroid point using Euclidean distance, yeah, and take like minimum minimum numbers, yeah, so list the closest numbers to these centroids. So we should like select 5 of them. So, and we do this distance calculation iteratively, yeah. So there is some other case is Manhattan distance, yeah. So this is just some of the horizontal or vertical components distance between 2 points, yeah, measured along axis at right angles. So this is simple sum of horizontal or vertical components. So this is another version of Euclidean distance instead of using Euclidean distance, yeah. There is exists like silhouette coefficient, yeah, or call it silhouette score, yeah. This is a metric in order to evaluate how your data set is clustered, yeah, how well is clustered your data set. So if this silhouette coefficient is close to 1, so it means it's your data set is clearly distinguished, yeah, clearly divided into groups, yeah, or into different clusters. If 0, so if this silhouette coefficient is equal to 0, it means like classes are indifferent and it's difficult to distinguish. If this silhouette coefficient is equal to -1, so it means clustering happened in very bad way, yeah. So this is a measure of bad clustering. How it look like this silhouette coefficient, yeah. So as you can see here, we measure distance, yeah. So here, so we measure like distances between, for example, we choose some point, yeah, and we measure all the distance between all points, yeah, here near to within this cluster. And here we also calculate distance between I and the nearest cluster centroid, yeah. So we choose we calculate distance between so as you can see, we calculate this and also divide like to the maximum distance. So this is a measure how your data points is clustered into different separate clusters. So a measure of goodness of clustering. Here, in order to remember, I told in this k-means clustering algorithm, we should choose by ourselves the value k, yeah. So in order to choose this value, exists term called within cluster sum of squares, yeah, which measure of total variations within the cluster, yeah. So as you can see, xj with hat is a sample mean in J cluster, yeah. So here, as you can see, we just calculate this error, yeah. And as you can see, we should choose the point where, for example, error was decreasing in rapidly, yeah, in stiff way, and then at some key value, error started to decrease, not like in stiff, yeah, but it smoothly, yeah. So it means we choose in this like as an elbow shape point. So this is optimal value to stop on choice of value k, yeah. So here, using this equation, we can identify optimal value k. So here, general pipeline of k-mean algorithm, in which first you do some scatter plot, determine you set up some value for k, yeah, and then you initialize some centroid, you choose some centroid and start measure the distance, yeah, between other data points. Based on this distance, you assign to the nearest cluster, yeah, and after that you form new. After doing this, calculating distances between other data points, you move to the new centroid and measure also variance, and you provide some cluster, and you again start this process here. So here you do this process iteratively from step 3 to step 5 until you have until measure of the variance will be good. So where is this k-means algorithm, clustering algorithm used? So it can be used to segmentation, image segmentation, yeah. So segmentation, it means you, for example, you have some image, yeah. So in this image, you want to separate different objects, yeah. So you just, for example, you want to identify edge of human in the image of the human. You want to identify edge of this human and some other objects, yeah, surrounding objects. So in such case, for example, k-means algorithm can be used. It's also used in natural language processing for document clustering. It also can be used in businesses, yeah, for customer segmentation, yeah, based on some different properties like buying behavior, and demographics, and some other properties. It also can be used in a recommendation system, yeah. So in all of these attributes in which based of this you want to cluster, yeah, separate into different classes, this distance measure is implemented, yeah. So as we mentioned before, it can be Euclidean distance or Manhattan distance, and it can be used also in anomaly detection, yeah. So for example, imagine like you have a white background, yeah, and within of this white background you have some object. So as this object differs from, for example, let's say in white background you have black objects. So if we measure like pixels, yeah, of course this object will be classified as a one separate cluster, and it can be considered as a anomaly, yeah, in your image. So this is different application of k-means algorithm. So if we talk about advantage, k-means algorithm is easy to understand, yeah. So you just plot scatter plot, you choose some centroid point and start to measure distance, and you choose the maximum close to the centroid like k number, yeah, and then you assign into one separate cluster. So it can handle large data set, and it can be scaled easily, yeah. So k-means, as we told, unsupervised learning. So you don't need to provide labels here. So it means it can be used in different field, but it also has always any algorithm has its own disadvantage, yeah. So what is this? So as you can see, performance of this algorithm can be varied depending on which initial data points you choose, yeah. Also, it's very sensitive to the outlier. So if in your data there is some outliers or some noise, it cannot understand, yeah, distinguish if it's noise or it's contributing information. So if these clusters usually like has convex shape or spherical shape, this algorithm works very well. But in some other non-convex shape case, this algorithm fails. So here we have a code implementation, yeah. So as we told before, in order to implement k-means algorithm, we need to use centroids, yeah. So here, for each training example, we should find some centroids, yeah. Also, regarding to these centroids, we also calculate mean value, yeah, mean of each centroid. So here, finding closest centroid function definition. Here, the calculation of like within mean centroid and with each data point distances, yeah. So here we have a calculation of centroid calculation, yeah. So here we calculating mean value. Yeah, you can take a closer look for this code, yeah, yourself. But for now, here after implementation for image, yeah. So as you can see here in 3D plot, we have pixels color distribution, yeah. We have color distribution in 3D coordinate state of this image, and also color distribution, yeah, here in one-dimensional matrix. And using this knowledge, we can, for example, compress, yeah. So originally we had this kind of image, and using this k-means clustering, we compressed image, yeah. So it means we, for example, closest pixel value, we calculated mean value and replaced with mean value, yes. So this is how this image compression can be done using k-means algorithm. And now we're going to talk about second algorithm, yeah, shortly. This is called density-based spatial clustering of applications with noise, yeah. So this, as we mentioned before, k-means algorithm is good, but it doesn't work properly if shape is spherical or not spherical and not convex, yeah. It also works good even in case of outliers. Here we also provide like minimum points, yeah. So this is a minimum number of points threshold clustered together, yeah, for a region to be considered as a dense. Also, we should provide like epsilon value, a distance measure that will be used to locate the points to the neighborhood of any point. So we also here give some minimum point value, and the epsilon here we also provide the distance, yeah, which helps to algorithm to understand for how long in how long distance points, yeah, how far located point can be considered as a one cluster, yeah. So we also provide some distance measure. As you can see here, there is two term, yeah. So first one is density reachability. So we say like these points are reachable if these points lies within this epsilon distance, yeah. If it's less than this distance that we provided, so this point is called reachable. And the density connectivity term, it helps us to understand if this data points is located within one cluster, yeah. So as you can see here in the from the plot, these points, for example, P and the Q, are densely connected to each other. So we in the density-based clustering, yeah, with noise, we have 3 data points, data types. So first one is core data point, yeah. This core data point, we say core data point if within this epsilon distance, minimum data points is if it's located, we say this core data point. We also say like there is border data point, yeah. So we say this border data point, if it's not inside of this core data point, but within epsilon distance regarding this core data point, yeah. So initially we have in the sum circle some number minimum amount of points, yeah, within the epsilon distance. But so if within this core data point there is also another point which is within epsilon distance, we also say this border data point. But other data points which is far from this epsilon, we say kind as a noise. So which is not core data point or border data point, we say it will be considered as a noise. How this algorithm works? So we start from random unvisited data, yeah. So all data points within some epsilon distance will be considered as a neighbor points, yeah, neighborhood points. So as you can see, also data within this epsilon distance is considered as a one cluster. So if this minimum points is not within like reachable distance, it will be considered as a noise. So as you can see, all the data points within this epsilon distance will be considered one group. So as you can see, after filling outer loop, started this other data points here, and as you can see, all of these data points is within some reachable epsilon distance, and so now you can see this blue points is considered as another cluster. As you can see, there is no data point. Then we move further, some other left data set. And as you can see, these data points is within reachable epsilon distance, and then now it's new cluster. So this is how clustering process happens. Yeah. Here is some another example. Here we have some X data and the Y data. Yeah. And here we can calculate the distance between these two data points. Yeah. So it's initially like some random numbers, yeah. But later we can calculate distance between these two data points, yeah. Here epsilon is taken as 0.6 and the minimum points is 4. And here you can see like there is already started some division into different clusters, yeah. This data, yeah, you can also look for this example, make a closer look, yeah. And at the second iteration, you can see there is some data is labeled with yellow and blue, yeah. So this clustering, as you can see here, now we have some new labels, which is called the border point, yeah, which distance, based on which distance it's called like border point, and there is core points, yeah. So as you can see, these yellow ones then is divided as a cluster 2, and the red one is considered as a class 1. And there is some data points is few data points is considered as outliers. So here advantage of dbscan over k-means is that k-means works only for spherical data, yeah, but it fails when data is not spherical in nature. So also k-means is sensitive to outliers, but as you can see, dbscan works, this clustering works much more better if it's not even spherical, or also it's not sensitive to the noises. It can like even identify noises as outliers, yeah, as you can see here in this example. So here code implementation of DBSCAN algorithm, yeah, from scikit-learn. So this code, as you can see here, scikit-learn dataset, which is called which is imported like make circles, and then as you can see here, minimum sample is 10, and the epsilon distance is 0.3, and then using this fit method, training process is start, and then this is what you see here, yeah, for example. That's it for today. This is unsupervised learning in which you don't give any you are not given any labels, yeah, but your algorithm itself should classify into different clusters, into groups, yeah, based on some properties. And as you can see in both cases, you always measure the distance between these properties, yeah, and if these properties are closer, you can consider as a one group, as a one cluster. If it's not, then another cluster or another group, yeah. So that's it for today, and thank you for your attention. Bye bye.